This is strictly for your information, but to find the least squares quadratic function of best fit, like a parabola, y equals ax squared plus bx plus c, for a set of data points given, we need to find the a, b, and the c, so we can plug them into this, and then we have our least squares quadratic function fit. And we want to find the a, b, and c, so the squares of the differences between the y sub I, in other words these points, and the predicted y sub I, so a x I squared plus b x I plus c, is minimal. So we need to construct a function of three variables, a, b, and c. That's these variables. And the function s with variables a, b, and c that describe the differences would be y sub I for each of the I from 1 to n, yi minus, and this would be the quadratic function of best fit, a xi squared plus b xi minus c. All that squared because we want the squared differences, keeping in mind that if you just add up the differences, you always get 0 if it passes through the centroid. So we need to add up the squares of the differences and then minimize that. So if we're going to minimize that, we take partial derivatives with respect to a. Of course, with respect to a, we have 2 times this entire function times the derivative of the inside part. So there's 2 times the inside function times the derivative of the inside part with respect to a, and that would just be negative xi squared. And that must be 0 if it's going to be a critical point. And we can do the same thing with b. So the partial derivative of this function with respect to b is 2 times the inside part times the derivative of this term, the inside part, with respect to b. The rest, of course, are 0 because b doesn't occur. So that's times negative xi, and that also equals 0. And then we do the same thing with c. So the partial with respect to c, and remember all these partials have to be 0. So 2 times all this times the derivative of the inside function, which would be negative 1. And so then that also has to be 0. Okay. Using this equation for SA, that's this one right here, okay, we know that all this is equal to 0. A, B, and C are constants, and factor out. 2 can be canceled out of every term, and actually a, b, and c are the constants we're trying to find, and they can be factored out. And these sums of the xi squared, some of the xi's cubed, some of the xi's to the fourth, some of the xi's squared, and the yi, they're all numbers we can get from our data set. So then a times this plus b times this plus c times this equals this number times y. If you look carefully at it, see, this is in every term that contains the x to the fourth. So we factor that out of the x to the fourth. We've already canceled the 2's. And I think you can probably work out why this leads us to this. And it's not, as I said, a, b, and c aren't constants, but are, maybe it'd be better to say, in each term, and factor out. So 2 can be canceled, and you can figure out how that goes. All the sums are just numbers, as the data xi is all given. So all these summations are numbers. And so since that data is given, we can get a similar information from SB equation, this one, and again factoring out the A, B, and C as they occur, we get a second equation with A, B, and C as variables, and from the partial derivative with respect to C, that's from this one, where to go? This one, right? Again, with the factoring out of special numbers, we get A times this plus B times this plus C equals this, And again, we have this system of equations with variables A, B, and C, unknowns A, B, and C. The rest of these, every one of these summations is calculatable with, I think I would want to do it with software, but every one of these things is calculatable from our data set, the set of points xi, yi. And so with unknowns, and that can be easily solved, but honestly I'm not going to do it. If you were to say, how could I do that, maybe I could show you what Kramer's rule would make it look like, but it would be a god-awful mess. But remember that these are just numbers. And so these numbers can be found from our data set, plugged into here, and then we have an equation, a system of 3 equations with 3 unknowns, and that's not hard to solve.